A falling object travels a distance given by the formula d equals 8t plus 16 squared feet, where 16t squared feet, where t is measured in seconds. How long will it take for the object to travel 168 feet? So we need to make sure we first understand the problem before we jump into trying to find an answer. So we have a falling object. So we have some object that's starting up above, let's call this ground level, and it's falling downward, okay? Now, we have time, so time equals 0, and then at some time later on it hits ground, so time equals some point there. Now, at each point in time, say t equals 1, however far that would be away, then d, this function, measures how far away that is. And so at t equals 2, this would measure how far we've gone in 2 seconds, and so forth. So the question is, how long will it take for the object to travel 168 feet? Okay, well, let's see. So the distance that we want to travel is 168 feet. And we also know that the distance is measured by this formula right here. So if I take, since they're both equal to d, I can set them equal to one another. So 168 equals 8t plus 16t squared, which, if you'll notice, is a quadratic. And if I have a quadratic, I always want to get that quadratic set equal to 0. So I'll bring everything to one side and then try to factor. 168, that might be divisible by 8. Let's check and see. So 168 divided by 8 is 21. Great. The nice thing about that is I can divide both sides by 8, which will make my problem easier. So 2t squared plus t minus 21. So once I get everything set equal to 0, the common factors pulled out, I can try factoring this quadratic to see if I can determine what the solutions are that way. So I need two things that multiply to 2t squared. So 2t and t are my options. Two things that multiply to 21. It looks like my only options are 1 and 21 and 3 and 7. My guess is going to be 3 and 7 are worthwhile trying first, but we can see if this works, and if it does, great. If not, we'll try the 1 and 21. But it just seems to happen that the middle values, the middle factors, are usually the ones that are used. All right, so 3 times t would be 3t. 2t times 7 would be 14t. Unfortunately, there's no way of getting those to add up to 1. So let's try some different combinations. So we can switch the positions of the 7 and the 3. So that would be 7 times t, which is 7t, 3 times 2t, which would be 6t. And if the 7t is positive and the 6t is negative, then that would add up to positive 1. So a positive here, a negative there. So those add up to positive 1. 7 times negative 3 gives me negative 21. So these are the factors. And what I would need to do is set each of those linear factors now equal to 0 and solve. So that 2t equals negative 7, or t equals negative 7 halves. And on this side, t equals 3. Now, I think it's pretty safe to throw out this solution because t is going to have to be greater than or equal to 0. Time here is a physical dimension, and so we can't go back in time. So t equals 3 is the only solution that really makes sense. So the length of time it will take the object to travel 168 feet is 3 seconds.